Welcome to the part 4 of array implementation of stacks. In this presentation, we will learn how to write this function called isFull function. We will also learn how to write isEmpty function, and we will actually update our main function. So without any further delay, let's get started. First, we will write isFull function. In the push function, we were checking whether a stack is full or not. We already know how push function works, right? Push function is capable of pushing an element onto stack. Before pushing an element, we were always checking this condition whether a stack is full or not, right? This is how push function looks like. We have already seen this in our previous presentations, right? In this push function, you can see that first we are checking this condition. If top is equal to max minus 1, then we will simply print this message, stack overflow. We are asking the computer to print this message, stack overflow, if stack is full, right? Otherwise, we'll ask the computer to increment the top and put the data inside stack ARR top. That's what we will do. This is what the push function is all about, right? We already know this push function, how this push function works, right? Here we are checking this condition. If top is equal to max minus 1, then we will print stack overflow. This means we are checking whether a stack is full or not. Now maybe in future user wants to know whether a stack is full or not before pushing an element onto stack. Here also before pushing an element, this condition is checked. But maybe user is interested in checking this separately. Not before pushing an element, not before doing anything. Maybe he or she just wants to check whether a stack is full or not, right? For this purpose, we have to write a separate function called isFull, which will check whether a stack is full or not and will either return 0 or 1. This function returns 0 if the stack is not full. If the stack is full, then this function will return 1. Okay? So it is always a good idea to write a function isFull to check whether a stack is full or not. So here instead of writing top equals to max minus 1, instead of checking this condition, what we will do, we'll simply call isFull function. If this will get replaced by 1, then it simply means that stack is full. If it is replaced by 0, then this means that stack is not full, right? IsFull will either return 1 or 0. As I've already told you, this function will either return 0 or 1. If isFull returns 1, then it indicates that the stack is full. This means isFull will get replaced by 1, and 1 means true, right? If true means the condition is satisfied, which means we'll get inside, that is, we'll print this message on the screen, stack overflow, right? If it is the case that isFull returns 0, then it indicates that the stack is not full, hence the code after if construct will be evaluated. Isn't that so? If at all it is the case that this function returns 0, then it indicates that the stack is not full, hence this piece of code will get evaluated. Okay? This is how isFull function looks like. Here we are simply checking this condition. Is top equal to max minus 1? If it is the case, then we will return 1, otherwise we will return 0. Returning 1 means stack is full. Returning 0 means stack is not full. Okay, now we will write a separate function for checking whether a stack is empty or not, right? It is important to check whether a stack is empty, and we know that we are already checking this condition inside the pop function, if you remember this, right? We are checking this condition whether a stack is empty or not before popping an element out of stack, right? This is how a pop function looks like. Here first the variable is declared. Then after this, we are checking this condition. Is top equal to minus 1? If at all it is the case that top is equal to minus 1, then we will simply ask the computer to print this message, stack underflow, and exit from the program with this status, that is exit failure status, right? And after this, of course, if it is the case that this condition is not satisfied, then we will evaluate this piece of code. This means we are asking the computer to evaluate this piece of code, right? Now, instead of checking this condition, we can replace this by this function isEmpty, which we will obviously define, right? And this is required because maybe user wants to know whether a stack is empty or not before popping an element out of stack, or maybe he or she just wants to check whether a stack is empty or not. It is a good idea to write this function separately, that is isEmpty function separately, okay? This is how isEmpty function looks like. And in this function, we are checking this condition if top is equal to minus 1. If it is the case that top is equal to minus 1, then return 1, otherwise return 0. Simple. This is all what we should remember. And please note that the return type is integer. It is important because we are returning an integer value, right? That is why the return type has to be integer. Now, it's time for updating the main function. We must update the main function. This is what we should do at last, right? We must update the main function. Let's see how to update the main function. Our requirement is to simply ask the user these things. These are all the options available for the user. Either user can push an element, either user can pop an element, either he or she can print the top element, either he or she can print all the elements of the stack, or maybe the user can select this option, that is quit. So we'll ask the user to enter your choice. So first we want to print all these things on the screen, and then after this the user would be able to see this, that please enter your choice. We are asking the user to enter the choice. Okay. It might be possible that user will enter 1. This simply means that user wants to push an element onto stack, right? In that case, we will ask the user to enter the element to be pushed. Maybe user will enter 23. Then, this element must be pushed inside the stack. Simple. After this, again, we will ask this to the user. We'll ask the user to enter the choice. Now this time, it might be possible user will enter 3. This means that user is interested in printing the top element. In that case, this message must be printed on the screen, that is the topmost element of the stack is 23, because user has inserted 23 element onto stack. Therefore, the topmost element of the stack is 23. This is the only element and this is the topmost element, right? After this, again we will ask the user to enter the choice. This time it might be possible the user will enter 4. This means user is interested in printing all the elements of the stack. We know that there is just one element in the stack, that's why 23 will get printed on the screen. Simple, right? And it might also be possible that next time user will enter 2. This means user is interested in popping an element out of the stack. And we know that the topmost element will get popped out of stack. And we must print that element on the screen as well. So this message must be printed, that is deleted element is 23. We know that 23 is the only element in the stack. Therefore, the deleted element is 23, right? Again, we have to ask this user, please enter your choice. Let's say this time user enters 5. Then, in that case, this message will get printed. Process returned 1. This means we want that program must be terminated with this status. That is exit failure. Okay? And obviously we know that after this message will automatically get printed on the screen. That is press any key to continue. Now this means that user wants to quit and that's it. So obviously in the main function, first we will declare two variables, choice and data, right? Choice variable is required to store the choice entered by the user and data variable is required to store the data, maybe the deleted data or maybe the data that the user wants to push, right? Now requirement 1 is to print all these things on the screen. For this purpose, we will write this piece of code. And let me tell you that this piece of code must be written within this while loop. And here I have put this 1 over here, which means that this while loop will run infinite amount of time. Okay. We will continue to ask this to the user. If user enters 5, then we will exit out of this program. As simple as that. Okay. So here this loop will run infinitely. Here you can see first this message will get printed on the screen. 1.push, then 2.pop, 3.print the top element, 4.print all the elements of the stack, 5.quit. And finally, this message will get printed on the screen, that is please enter your choice. And that particular choice we will simply store within this choice variable. Fine. After this is requirement number 2. After asking the user to enter their choice, it might be possible that user has entered 1. In that case, we must print this message, that is enter the element to be pushed. Then user will enter some element and we will store that element within the data variable. Okay. And we will also push that element onto stack. This is what we should do. So we will use switch case for this purpose because we have multiple cases, right? If choice is 1, that is, if the user has entered 1, then in that case, this message must get printed on the screen, that is enter the element to be pushed. In that case, the element entered must be stored inside the data variable and then this data must be pushed onto stack using push function. After this, the break must be called. This is important. We know this already that after every case, we must put this keyword break, right? So this is case 1. Case 1 is asking the user to enter the element to be pushed. If user has entered 1, this means that user wants to push an element. That's why this step is required. It might be possible that user has entered 2. Then in that case, this message must get printed on the screen. That is, deleted element is 23. Right? So this is case 2. This is how it looks like. Here we will call pop function. And also we know that pop function will return the deleted element. So we'll store that deleted element inside data variable. And here after this, we'll print this message on the screen, that is deleted element is %d. We know that at runtime, this %d will get replaced by data, right? After this break keyword is required to break out of the switch case, right? We'll continue to ask this to the user. Please enter your choice. Please enter your choice. Okay. After entering the choice, we will check what choice is entered by the user. It might be possible that user has entered 1. This means that we must push an element onto stack. It might be possible that user has entered 2. In that case, we must delete an element out of the stack. It might also be possible that user has entered 5. In that case, we must terminate the program, right? This means that we'll get outside of this while loop and actually this whole program will get finished, right? For that purpose, we'll call exit function, okay? You know that we can add the rest of the cases. It is not very difficult. But let me just show the complete code in code blocks. This is the complete code in front of you. You can see is full function is here, right? We have is empty function. We have push function. Then we have this pop function. We have this peek function also, okay? This peek function will actually give us the topmost element of the stack, okay? Here we are checking if is empty. This means that we are checking if the stack is empty, then we will print this message stack underflow. Otherwise, we will simply return stack ARR top. This is what the peek function does. Okay. After this, we have this print function to print all the elements on the screen. Then we have this main function. Here you can see in this main function, we have this while loop, okay, which runs infinitely. And here inside this, we have all these statements. After this, we have the switch case, and we have already seen the first two cases, that is case 1 and case 2. It is simple, right? Then we have case 3. If the user has entered this choice 3, then it means that user is interested in printing the top element, right? This means that we will call this printf function with this message, that is the topmost element of the stack is %d. This %d will get replaced by the value returned by this function, peek, right? This peek function will return the topmost element of the stack. Isn't that so? So here we are simply calling the peek function. Now, if user has entered 4, then this means that he or she is interested in printing all the elements of the stack. In that case, we must call the print function, and that's it. Every time you can see I'm putting this break keyword, right? This is important. You must write break after every case. Fine? After this, we have this case 5, which means simply quit, that is terminate the program, right? Here you can see I'm simply calling exit function with this status, that is exit failure status, right? And then we have this default case. It might also be possible that user will enter a value other than these 5 values, right? So at that time, this message must get printed on the screen, that is wrong choice, right? And that's it. This is how the main function looks like. Okay. Now let me just execute this code. Okay. Let's enter the choice. Let's say we want to push an element onto stack. Enter the element to be pushed. Let's say it is 23. Okay. This means that element is pushed inside the stack, right? You can also add a message after this that the element is pushed inside the stack. Okay. Now let's enter some value here. Let's say this time we want to print the top element. You can see the topmost element of the stack is 23, right? This is correct. After this, let's say we are interested in pushing one more element. Let's say this time we will push 45. Okay. Then let's say I'm interested in printing the top element. This time you can see the topmost element of the stack is 45, right? Because this is the last inserted element. Okay. Let's say I'm interested in printing all the elements of the stack. You can see 45 and 23 is printed. Now we want to push one more element, this time 56. And let's say I want to print all the elements. You can see all the elements of the stack, 56, 45, 23. This is the topmost element, and this is second topmost element, and this is the last element of the stack, right? Now I want to quit. So I will enter 5. And you can see process returned 1 gets printed on the screen. And here it is asking us to press any key to continue. I simply press enter. We'll get outside of this command prompt. Simple, right? Okay friends, this is it for now. Thank you for watching this presentation.